Hello everyone, I'm Jay Joshi and welcome to the 16th episode of Learning Java. Today, we'll be learning about type conversions. So, what is type conversion? Type conversion is basically the process of converting one predefined data type into another. So, in simple terms, let's say we have an integer and we want to convert that to a double. So, we are converting from one data type to another, that is, in this case, from integer to double. So, that is what type conversion means. So, it can be from anything from double to integer, integer to double, float to double, double to float, and there are other various examples. So, there are two main types of conversions: implicit type conversion and explicit type conversion. So, we'll be looking into both of these. So first we'll be looking into the implicit time conversion. So this type of conversion is also known as promotion or coercion, and implicit, as the name suggests, it happens automatically. So the programmer does not need to do it. It happens implicitly inside the computer automatically. So it happens without the programmer's intervention. So implicit type conversion is basically conversion from a smaller data type to a larger data type. So that's what you have to remember. Implicit means conversion from a smaller data type to a larger data type. Now you might remember this order of data type. So we have Boolean is the smallest. We have byte, char, short, int, long, float, and double. So this is the order of the data types. And so let's say we want to convert from char to float. So it's conversion from a smaller data type to a larger data type. So it'll be implicit type conversion. If we want to convert from byte to double, it's small to big, so it's implicit type conversion. So the main reason for this implicit type conversion, which happens automatically, is to prevent loss of data. So we'll just have a look at a couple of examples. So let's say we have int n is equal to 12, and then we perform an arithmetic operation with double n1 is equal to n into 4.5. Now you might know that since this is a double value 4.5, this 12 integer gets converted to a double internally, implicitly, to perform the operation so that the output is double as well. So since this operand is a double, the integer will also get converted to double, so it'll become 12.0 to prevent loss of data. So just in case there's some loss of data, it'll convert the smaller data type to a larger. So in this case 12 will get converted to double, which is 12.0. So it'll perform the operation 12.0 into 4.5, and then the value will be stored in n1. But an important point to remember is that this n will stay as 12. The n gets converted to double only in this particular operation. Any other operation performed after that will, in that, n will remain integer only. So let's say after we perform double n1 is equal to this, and we do system.out.println n, the output will be 12, not 12.0, because it's still 12. The value is still an integer. Only in this particular arithmetic expression, it gets converted to double. So this happens automatically. Now we'll be looking into another example. So let's say we have char c is equal to capital A, and then we do int b is equal to c. So the value of c, which is the char A, capital A, will be stored in the integer value b. Now it can't store A and B, so what will it store? So you might remember we had the ASCII table, and we know that 65, so you can see 65 over here is A. So this is the particular Unicode value in Java for capital A. So A in arithmetic form, capital A represents 65 because of this table, Unicode characters. So when int b is equal to c, when Java performs this operation, the Unicode character value of the letter will be stored in b. So it's going to convert capital A to its Unicode value, which is 65, and then B will store 65. And since this will happen automatically because it's conversion from a smaller data type, which is char, to a larger data type, which is int. So according to this order, so char and then int. So these are the two basic examples of implicit type conversion, and you can see how this happens automatically within your programs. Now we'll be looking into the explicit type conversion. So as the name suggests, this is also known as typecasting. So this particular type conversion the programmer has to do it. It does not happen implicitly. The programmer has to do it explicitly. And it's basically a conversion from a larger data type to a smaller data type. So you can see how it's completely opposite of implicit type conversion. Implicit happens on its own, while explicit the programmer needs to do. Implicit is from a smaller data type to a larger data type, but explicit conversion is from a larger data type to a smaller data type. An example would be to convert from double to, let's say, int, to convert from float to char, long to byte. This is what explicit type conversion is, larger to smaller data type, and the programmer has to do it on his own. Now, there are some disadvantages of explicit type conversion, which I'll be covering in the next slide, but first we'll be look at some examples. So let's say we have double B is equal to 345.67. So this is a double. And let's say we want to convert this double to float. So it's conversion from a larger data type to a smaller data type, double to float. So the way we do this is we write the particular variable for that data type, and we put the particular data type to which we want the variable to get converted in brackets, and then we put the particular variable or literal. So another way of writing this would be float, and instead of writing b we can also write directly 345.67, and it'll convert this to its, you can write float parenthesis and then the particular double or anything else which is larger than float, which is only double, so double in this case. So we'll convert the double b into its float equivalent. Another case over here would be int b is equal to 97. And let's say we want to convert this to character. So since int is a larger data type as compared to character, it'll be explicit type conversion. So the programmer will have to type something. So since the variable is b, we write that at the end, and we want to convert it to character. So we write the character in the brackets. And so this 97 value will get converted into character. And we know that the 97 Unicode character is actually small a. So you can see 97 and this is small a character. So char ch will store the value of small a, because this particular 97 is the Unicode character of small a, which gets converted to char. So char ch will store small a. So these are the case examples of explicit type conversion. Now we'll be looking into some problems which can arise in explicit type conversion. So let's say we have something like float b is equal to 3.88f. You remember we put suffixes when we initialize float and long. And we convert this float into integer. Now you might know that integer does not have any decimal values. So when this float gets converted to an integer, its decimal values will go away, and the g over here in g will store only 3. So you will lose the decimal values. Now this can be an advantage and a disadvantage in some case. So there's just a reminder that you will lose some part of your data when you convert a higher data type to a smaller data type. Another example would be, let's say you have an integer 625, and then you convert that integer into a smaller one, which is short in this case. But short data type in short byte long, so short cannot store a number as big as 625. So we'll store the largest number possible in its case. So I think that's around 127. I'm not too sure, but it's going to store the number which is largest in its case. It won't store 625 because short isn't big enough to store a number as big as this. So again, this will result in loss of data, and it can lead to some logical errors. The final case is if you convert a double to float, so a larger data type to a smaller data type, and double can store a particular set of decimal values. So it has like around 15, 16 digits it can store, but float has lesser, it can store about 8 to 9 um, digits. So there might be a loss of the decimal places when you convert a double to a float. So this G will only store, let's say for example, till here. It won't store this 5, 6. It depends on how much space that double and float will occupy. So in all three cases, explicit type conversion can lead to the loss of data while converting. Another important example of explicit type conversion is this. So I want you guys to predict the output of this. So let's say we have char ch is equal to a, capital A, and we do this char ch1, a new variable, and we do ch plus 2, so a plus 2, and then we convert this to char. So what will be the output? Now over here, you can't perform an operation capital A plus 2. So what Java will do internally, it'll do implicit type conversion. It'll convert this capital A into its equivalent form, Unicode character form, which is 65. So it'll do, this is implicit type conversion from character to integer. So it'll be 65 plus 2, which will come to 67. And then we are converting the 67 explicitly into character, which is a smaller data type as compared to integer. So the value of 67, according to the Unicode character, will be C. So you can see 67 is C. So character C1, CH1 will store the value of capital C. So you can see in this example how there's both implicit and explicit type conversion implemented. Now, this was one of the most common examples to help better understand the concept. Now, another doubt which many people have in type conversion is about Boolean and string. So we need to remember that we cannot use type conversions with Boolean and string. So anything like a statement like this will not work. It'll throw an error. You can't convert integer or any other data type to a Boolean, or vice versa. You can't convert integer to Boolean or Boolean to integer or float to integer or anything. So type conversions should not involve Boolean and string. Like even in this case, you're trying to convert hello to integer, and if you do it the vice versa way, if you convert let's say the number 4 to a string using this way, you can't do it. Although there are other ways of converting an integer to a string or string to an integer, but you can't do it in this way using type conversion. And I'll be covering those ways in which you can do that in a later video. But quick note to remember is that Boolean and string, you cannot use explicit type conversion, and it will not happen implicitly as well. So that's it for today, everyone. Thanks for watching. And if you have any queries, doubts, or suggestions, you can mail me. My email will be in the description down below. And thanks again for watching.